All right, so it's about time, so let's just get started. So good day, everyone. Welcome to today's Youth AI Talk, and we're very excited to have you here. Before introducing today's talk, I would like to give just a brief overview of the Youth AI speaker series and our mission, because we have quite a few new audience members here today. To raise awareness of AI among all communities, we invite experts from academia and industry to share their knowledge and discoveries in specific areas of AI. Unlike other technical talks, these talks will be tailored to people without much background in AI. Therefore, they're hopefully engaging to listen to and easy to follow. We hope that by listening to these talks regularly, you can gain a solid understanding of AI and help you get more invested in this emerging technology. And thank you for tuning in tonight and your support for our initiatives. We've hosted 14 fantastic talks since the kickoff of the Youth AI Speaker Series last August, covering important areas of AI such as efficient AI, graphics AI, cognitive AI, finance AI, as well as different implications of AI. Replays of these talks are mostly available on the Youth AI YouTube channel, with the exception of a couple of talks. And we're proud that we've reached more than 6,000 people with over 20,000 views through our live Zoom meetings and our YouTube channel. I'd just like to briefly go over our last talk featuring Professor Boahen from Stanford University, who shared his pioneering research in building brain-like computer chips and their potential impacts on AI. You're welcome to watch the replay of this talk on our YouTube channel at youtube.com/YouthAILab. And we have an upcoming talk on June 12th. We will feature Professor Adam Clevens, who will share the research vision for the new NSF AI Institute for Foundations of Machine Learning, as well as some of its educational and outreach components. He will discuss how algorithms will play a major role and give examples from recent work. He is a professor of computer science at UT Austin and the director of the new NSF AI Institute for Foundations of Machine Learning and director of the UT Austin Machine Learning Lab. Pre-registration is on youthaitalk15.eventbrite.com, and I'll be putting these links in the chat. Next, my co-host Clarice Wong will share some logistics of today's talk.
Yeah, thank you, Jeffrey. So before introducing Dr. Halevy, I'd like to briefly go over the logistics of the talk. Because we have an audience watching from our YouTube live stream as well as on Zoom, we'll be doing a Q&A through a platform called Slido. Either go to the URL in the chat that Jeffrey will put in the chat, or go to Slido and enter event code 884790. That is 884790, as you can see on the slide. Feel free to submit questions throughout the talk, but we'll only be answering questions in the Q&A session at the end of Dr. Halevy's talk. So now let me introduce today's speaker, Dr. Alon Halevy. Dr. Halevy is currently the director of Facebook AI. He is a world-renowned computer scientist, a successful entrepreneur, and a world-leading expert in AI, machine learning, and natural language processing. Dr. Halevy has been leading AI and big data research efforts in various companies such as Facebook, Megagon Labs, and Google. He is a fellow of the ACM and a winner of the 2006 and 2018 VLDB 10-Year Best Paper Awards. Dr. Halevy joined Facebook as a director of AI in August 2019. But before that, he was the CEO of Megagon Labs. And before Megagon, Dr. Halevy spent 10 years at Google, leading the structured data group in Google Research. Dr. Halevy is also founder of two companies, Nimble Technology and Transformic Inc. He's also the author of The Infinite Emotions of Coffee, a book that looks at coffee culture around the world and of the principles of data integration. So today, Dr. Halevy will be talking about integrity in the age of AI, covering issues such as misinformation and fake news. So let's give a warm welcome to Dr. Halevy. Dr. Halevy, you may begin sharing your screen.
And I think you're muted right now, so just make sure to unmute.
Okay, that's a good idea. Now, okay, can you see my slides now?
I don't think we can see your slides right now. It's showing part of the PowerPoint presentation, but I think.
What if I?
This is the speaker view, but So I think you need to switch to view, to the audience view.
Is better?
I think you might have to retry the screen share.
Okay.
Yeah, that looks good.
Okay.
It's perfect.
Worked 5 minutes ago, then it doesn't work now. That's usual. Thank you very much for having me today, and thank you for that very kind introduction. I'm going to be talking about a topic that is near and dear to many, many hearts, and very important for society today. And it's about preserving integrity in online networks. I will explain what this is in gory detail in the next few minutes, and then we'll dive into solutions or possible solutions to how to address this problem. Now, the talk, I'm giving talk, but there's also a very detailed survey that we wrote with a bunch of colleagues at Facebook a few months ago. You can find it in archive. It has the same title as the talk itself, and it goes into some of the details of the issues. So if you missed something, or if you're actually interested in this, go over there. So what is the problem that we're addressing today? So we know that social networks actually bring a lot of good to society, right? Social networks enable people to come together. They give everybody a voice, whether it's a famous person or your next door neighbor. It really is an enabler of many, many interactions that were unimaginable before they came about. When I talk about social networks, I'm talking about Facebook, Twitter, to some extent YouTube, and Pinterest, and all a bunch of them, WeChat. Now, there's on my slide, there's a screenshot just to prove to you that Facebook does do good for the world. A few years ago, this is a story that is told to every employee that joins Facebook, is told the story that in, this was, I guess, 2014, Facebook went down, we had an outage, and people started calling 911, okay? And the police chief of Los Angeles had to, tweet that, Facebook is not a law enforcement issue, and they're not holding Facebook servers hostage or anything. So I think that gives you a hint that maybe that social networks are actually a really good thing. The problem is, whenever you have a technology that is very empowering, you also bring out what I would call the worst in humanity. So people will find ways to use the system in order to do bad things. So spreading misinformation is one of the prime examples. Posting hate speech towards various groups is another example, but there are all kinds of other things like selling illegal items or bullying people or posting graphic violence or inciting people to violence that are also done on social networks, and we want to prevent that. So integrity is the field of keeping the network, the platform, free of all these harms, okay? Because if people come to social networks and they have these experiences, these are extremely negative experiences. They're bad for individuals, they're bad for society. They can cause various, they can cause a lot of societal harms. So this is what we're trying to solve. Now, how do we do this? So there are two very, very difficult steps to this. One is the companies that run these services, they write down policies, what is allowed and what is not allowed to post or to interact on a social network. Now, writing these policies is extremely difficult because it's very nuanced and needs to take into consideration the law, and needs to take into consideration cultural nuances and serving people all around the world. So those policies are not set in stone. They change quite frequently. Once you have the policies, Then you have the technical problem of setting up systems that will enforce these policies and make sure that content that doesn't adhere to the policy doesn't appear on the social network. So you might ask, well, let's just hire a bunch of people and they will look at every post that comes in and every message that goes between people and every ad, and they will and we'll just throw humans at the problem and we can use AI for other things. Well, that doesn't work. So I did the math here just to give you an example. Let's suppose we have 1 billion posts a day. Now I chose 1 billion because it's a round number, but we know that it's much more than that. Okay. Now, so now you want to have humans looking at every post and trying to figure out, is this allowed or is this not allowed? Now you need at least 3 people looking at every post because you might have disagreement, and so you need at least 3 people so you can actually break a tie. Now it takes some time to figure out. These policies can be very intricate and the content can be very subtle. So I'm giving it, say, 2 minutes per reviewer per post to determine whether something is violating or not. Okay, and that's not. I'm being generous here. I'm being conservative. In other words, some of them take longer. And I'm also assuming that people work 8 hours a day on this, which is also conservative because people who are looking at content that is problematic can't do this for 8 hours a day. So if you do the math, you'll find out that we need 12.5 million people to be hired by at least a company that supports 1 billion posts a day, and that's just not doable. Okay, so that solution isn't going to work, which means we need some automated methods, and this is where AI comes in. So the point of this is AI is not an option here. AI is critical in order to keep the content on the network free of bad stuff. Okay, so the amount of content is the first problem, which I already convinced you is a good enough reason to have AI. But there are other challenges as well. This content is expressed in over 100 languages. Okay, there are cultural nuances. When you say something in Italy versus in India versus here in the U.S., the same text might sound different or might have a different connotation. So you have to be sensitive to that. You have a lot of violation types. So I gave you a partial list, and I'll give you a longer one later. But there are like 50-something different violations that we track at Facebook. And not only that, even if you come up with solutions for keeping the network free of bad stuff, there are people who are going to try to trick you in order to trick your defenses in order to be able to post their stuff. Okay, so it's a very hard problem, and AI is going to be a necessary part of the solution. I also want to emphasize that not all people who post content that is violating the policies do this on purpose. Sometimes they just don't know, and if you tell them that their content is violating, they will fix it and they will be ashamed and never do it again. But there are people who do this on purpose, and those are ones we need to be especially careful of. Now, you could also say, well, let's just be very strict about this. Let's not allow certain words. Let's just keep the network clean by being very aggressive about what kind of content we allow. Well, that's not good too, because the whole idea of social networks is giving everybody a voice. Everybody should, this is a right in the Constitution. You should be able to say pretty much anything you want. And so if the social networks start enforcing policies that are extremely limiting, they're not serving their vision, and they're not serving society. Another point to keep in mind is that violations occur not just in posts themselves, not just when I post something on Facebook or Twitter, but they also occur in other stuff. They occur in replies to posts. So you might have a whole discussion that starts from a post, and then people start discussing, and people can start bullying other people or being hateful towards other groups of people. You can also have violations with accounts. You can have accounts that are fake and are there only in order to spread misinformation. You can have You can have violations in messaging. So in Messenger or in Twitter Direct or what have you, people are trying to use messaging in order to get people to do things that they shouldn't be doing. Now, messages are private. Messages are encrypted end to end. And so enforcing anything over there is even harder. And finally, integrity also happens in ads. So when people put ads or use Facebook or Twitter for ads, there are also rules that you have to comply to, and surprise, surprise, people try to get around that. So if I'm trying to sell illegal stuff, I might do it with an ad. So this talk, I'm going to try to give you some of the trends in the field. I'm trying to give you an explanation of some of the difficulties and some of the ideas for the solutions that people are trying out. This is not I'll give you examples from what's going on Facebook, but not everything I say should be seen as an endorsement by Facebook of a particular technique. Okay, you can see that this line in my slides was put in by a lawyer, so I'm quoting it to make lawyers happy. So there are two parts of the talk. The first one is the problem definition. So I'm going to talk about what these policies are and why they're so subtle. I'll talk about some of the enforcement mechanisms that are in place, and when you understand those enforcement mechanisms, you also sort of see what kind of technical solutions we can even consider in order to fit into that flow. And we'll talk about how do we measure that we are successful, right? We can put thousands of engineers on this thing. If we can't measure that we're making some sort of progress, then it's hard to justify any kind of investment. The second half of the talk, I'm going to be talking about some of the solutions. So some of the AI techniques that have been used here, some coming from natural language processing, some coming from computer vision. And when you put those two together, you get multi-modal reasoning, which is really cool. So I'll touch on that as well. Okay, so community policies. I have here, so the point of this slide is to show you that community policies are very nuanced. They're hard sometimes even for a person to understand. And so if it's very hard for a person to understand, try to think of an automated AI program that will try to do this for you. That is going to be even harder. Okay, so let's look at some of these nuances. So for example, you're not allowed to be on Facebook, to have a presence on Facebook, if you have a violent mission. If you're a terrorist organization, you cannot be on Facebook. Okay, you're not allowed to support groups like that. You're not allowed to support terrorists, or you're not allowed to support people who are inciting violence. Okay, so these are things that are explicitly not allowed. You're not allowed to say, go and bomb places or talk about going and using bombs for something. But you are allowed, and this is on the right-hand column, you are allowed to provide instructions on how to create or use explosives if it's clear from the context that it is for non-violent purposes. Okay, so it's something like part of commercial video games or clear scientific and educational purposes or fireworks. Okay, so you can see that this is very nuanced, right? You can talk about explosives, but only in very particular contexts. Another example is you're not allowed to sell firearms or illegal drugs on Facebook, but you are allowed to talk about the gun sale policies or crime laws and debate them. So you're encouraged to have civic debate about the issues that people in the country that you live in care about. So again, this is a very nuanced set of policies. And these change all the time. So for example, just last year, when COVID started, there were all kinds of violations that had to do with misinformation about COVID remedies and spreading misinformation like that, and they had to actually carve out new policies for COVID. There are also other things that make it very subtle, which is slight changes of tone change what you're actually saying. So for example, there are words, and I can't say them in a public talk, that are used to refer to certain populations. Okay, you can imagine for any protected population like Black people or Native Americans, or you have it, there are words that refer to people in that protected category. But those communities have actually sometimes adopted these words to talk to each other. Okay, they use that same word in order to refer to their friends in a casual or a funny way. Okay, so now it really depends on this. It's the same word, but it depends on who is using it and what context to figure out whether it's a violating post or not. It's also very hard to set absolute rules. I think everybody would agree that posting nude photos of children or anyone on a social network is allowed. But there's a very famous photo, which I did not put on the slide, but if you Google it, I gave you enough information on the slide that you can Google it. There's a Pulitzer Prize winning photo of a 9-year-old girl who's running away in Saigon during the Vietnam War, running away from a bunch of from a bombing, and that became a very iconic photo of the tragedy that happened of the war, and it's very well known. So it's part of our culture, right? So posting that photo is considered okay. Again, extremely subtle decisions here. So this is just a list of badness, just so you see that there are all kinds of things going on. I listed hate speech and misinformation, which are the two most, the ones that get the most information and the ones that are most prevalent at the end. But you have things like accounts that are abusive. You have obviously you have spam. You have all kinds of financial scams, people that are trying to get others to give them money. You have people who are encouraging suicide and self-injury, human trafficking. If you think of something bad, somebody has done it. Okay, that's not a surprise. Technology is a double-edged sword. You always see good and bad uses for it. So this is a colorful slide. This sort of shows you how a social network thinks about the flow of information and enforcement of these policies. So up on the top, you have the yellow box. Those are the activities that are happening. So people are creating accounts, they're posting stuff, they're commenting on other posts, they're sending messages. That is the part that is generating events in the social network. Now, every one of these events will go first in parallel. It'll be posted and it'll go to an AI system. Okay, this is where all the solutions that I'm going to be talking about, this is where they're employed. So an AI system will look at a post, for example, and it will try to figure out whether it's violating or not. Okay, if it's extremely confident that this is a very violating post, not very violent, it's a violating. Okay, then it will remove it. It will remove the post, and yeah, you can appeal later, and we take appeals all the time, and I won't go into that detail. If the system is suspecting, it's not extremely confident, but it is, but it thinks it might be violating, then what it does is it sends the post to a set of workforce of that the social network, in this case Facebook, employs. We're talking about many people, thousands of people that are trained to understand the policies of the social network. Okay, so they will look at the post and they will determine whether it's violating or not, and a decision, and then the enforcement will happen. This workflow applies for all kinds of violations except misinformation. Misinformation is when somebody's trying to say something, a fact that is not true. Okay, like a new COVID remedy, like Clorox, or that some politician did something or whatever. Okay, The reason, so when we suspect misinformation, the social network doesn't try to determine the truth. It sends it to third-party checkers. These are companies that have fact checkers that are trained in various fields like health or politics or what have you, and they make the decision of whether this is misinformation or not. Okay, and the reason this is true, this is actually a really important point. The reason this is true is that the social network, Twitter or Facebook, doesn't want to be in the position of deciding what's true in the world and what not. Right? We have enough stuff to worry about. We're not the mediators of truth on this planet. So that's why third-party fact checkers are employed for this task. Now, the other possibility is that a user will see a post and think that the post is violating, in which case they can report the post, and again, it will go through the same workflow. And that happens very, very frequently, obviously. So this is the way we manage the flow of content on the social network. Now, enforcement can look at different ways. So an account can be deleted, content can be deleted, content can be demoted, and I'll explain that in a moment. And in some cases, we might even call law enforcement if there's something that might cause imminent danger to people. Then law enforcement will be called and involved, and this obviously happens. Okay, so let's look at what enforcement means in a little bit more detail. Okay, so one way to enforce integrity is to remove the post. Okay, it's just deleted. Nobody's going to see it, and that's it. Okay, so if you're extremely confident that it's violating policy, that's what we will do, and that's pretty obvious. A lot of content is not that clear. It's sort of borderline violating. Okay, and trying to figure stuff out around the borderline is extremely hard. So another solution that social networks use is to downrank the content. So if you go to your Facebook stream or your Twitter stream, the social network is constantly ranking stuff for you, right? There's a whole bunch of content that it can show you from your friends and the people you follow, and we're constantly ranking that for you. So if we take something and we say, the rank of that thing is going to be lower, in other words, in the function that says where to put it in your ranked list of possible things to see, we're going to put it farther down, the probability that you'll see it is much, much lower, and then the damage that post can make is lower as well. In the same way, you can also personalize the removal and the downranking decision. So you can actually try to think of, if you know enough about people's preferences, okay, then you can actually try to think about that for some people, some content might make them feel bad, and for others it might not. And how do you do that? That's a very, very hard problem. Okay, but what I want to do here is, the point I'm trying to make here is there are different levels at which you can enforce integrity. The broader question that the community is starting to think about in, I would say, the last couple of years is it's not just about the bad stuff, okay? Because if you look at the percentage of content that you see on social networks, the percentage of bad stuff is extremely small. Okay, it's damaging and it's not good, and so we need to remove it. But most of the time, you're looking at stuff that is either good or boring, okay, or that you're indifferent towards. So now the question is, the much broader question is, how do we actually give you content that serves what you really need or what you really want? How do we balance between stuff that will give you short-term benefit, like the cat video, versus long-term benefit, like learning about something like about integrity? Okay, and this is a really, really hard problem, and it starts with it goes to a lot of philosophical roots of what it means for AI and humans to be aligned. So far, what we have on this is a bunch of books. One that I recommend is Human Compatible by Stuart Russell, a professor at Berkeley. Another one There's the one, the alignment problem. And then there's just a beautiful fiction by a Nobel laureate, Kazuo Ishiguro, that just came out a couple of months ago. A beautiful book that actually shows an example. It's fiction, but it shows a beautiful example of when it does work, when the humans and AI are aligned. So again, this is a problem that you're going to hear a lot about more in the future, but it's good to keep in mind. Okay, I'll talk about measurement for a minute. You can talk about that for a whole hour. How do you measure how well you're doing? Essentially, what you'd like to say is, look, the percent of content on the social network that is violating is below a certain threshold and is going down. Okay, so you show that it's 1% now, and next 6 months from now it'll be 0.5% and whatever. So that's the way you're measuring progress. The problem is you can't really do that because you can't count. You can't look at everything and decide how much of it is violating, right? Because we can't look at all the content. So what we do is we take a sample of some number of posts, and within that sample, we try to calculate how much, what fraction of it is violating and what fraction isn't. So that's okay, but not all posts have the same visibility, right? I might post something that 100 people will see, but then some politician will post something that that will be viewed by millions of people. So it's not really fair to count number of posts. We need to count the number of times people have seen a particular content. So what I posted would be counted for 100 times, and what the president posted would be counted millions of times. Okay, so this is what we call the prevalence of bad experiences, or we call it VPVs. I don't exactly know why. So that we do. But then you can go even further and say, well, not even if it's a violating post, not every violating post has the same damage, right? I mean, you can have something that is borderline nudity that may and will cause many people to be upset, but then there is mutilating an animal, which will cause many other people a much bigger number of people to be upset. So how do you determine the severity, in some sense? It's not just the number of people that see it, it's also the strength of the reaction, the negative reaction that people have when they see it. That's a hard problem. It's not an easy problem to solve. But those are the kinds of things that you need to think about when you're measuring success of integrity algorithms. One of the things that Facebook tries to do is to count the number of posts that we removed before users reported them to us. So that gives you some sort of indication that we're pretty proactive, and that's good. Actually, Facebook and others publish reports on this. So there's this huge incentive or more movement towards being transparent about what we're doing and how well we're doing on these things. So we publish every 6 months a full report of all the numbers that we're able to generate, and you can see it where things are getting better. Okay, so I hope I convinced you. This is a really hard problem to define, to process, and even to measure. So if you're thinking that this talk ends with a happy ending, it's work in progress. Okay, we're when you all start joining the workforce, we'll still be working on parts of it. So I hope to inspire you to think about this more. So now let's talk about the kind of solutions that people have employed to solve this. Now, before we go into the specific solutions, it's good to look at what do we have to go on? Okay, when we have a post or when we have something going on social network, what are the levers that we have that we can that an algorithm can leverage in order to figure out whether something is violating or not? So I divide this into 3 parts. One is the stuff that happens before the post is made, the post itself, and then what happens after the post is made. So before the post is made, you have accounts, you have people who are posting stuff. So if you know certain characteristics of certain people, like some people post a lot of hate speech. Okay, so by default, the prior of them posting more hate speech is higher than other people. So analyzing the characteristics of users or of groups of users that work together towards amplifying certain content is one of the things that one needs to focus on. Once you have the post, then you have a lot to go. Okay, so now you're looking at the content of the post itself. So a post will typically have text, image, maybe some video or audio, and often combinations of those. Okay, so at that point, you have the language that is in the post, you have the images that are in the post, and you have any other kind of reasoning that has to do with the content itself. And finally, after the post is made, you have the reactions of people. Okay, so people will react using these, the emojis that you can have like on Facebook or whatever. Or you can also have people writing comments. Okay, so people might write comments like, this is not true, this has been proven to be wrong, or this is so hateful, or this is, this makes me angry and sad. So the reactions that people have to a post are actually a great signal to tell you whether this is a violating post in some way or not. You'll also see after a post is made that people coordinate. You'll see that people try to amplify a particular post together. These are sometimes they're bots and sometimes they're real people. And these coordinated activities can actually cause more harms. But if you analyze the network of users on the network, then you can actually recognize these things. So there's a huge area of what's called graph analysis of the graph of users and the connections between them, that analyzing that can actually give you pretty strong clues about whether something is violating or not. So let's talk a little bit about natural language processing. So natural language processing is the field of looking at language and understanding it the same way a human would understand it, being able to answer questions on it, being able to answer whether it's violating or not, and telling all kinds of other nuances. Natural language processing is a field that is as old as artificial intelligence itself. It's made a huge amount of progress, I would say, in the last 5 years. It's been making solid progress throughout the last 2 decades, but it's a hard end, but it's nowhere near solved. Okay, so language, one message to take away from this talk is language is difficult. Another message is 100 languages are 100 times more difficult. Okay, so content on social networks is constantly being made in a variety of languages. And the other thing to remember about languages, there are languages that are being used a lot, like English or Chinese or Spanish. Okay, and so when a language is used a lot, then you have a lot of examples to train your machine learning systems. But then there are languages that are relatively scarce, like Burmese. And any technique that you develop for English won't necessarily work for Burmese because you just don't have the same amount of data in order to train your systems. Okay, so I'll go into details of natural language processing in a minute. And yes, computer vision is the field of looking at photos and trying to make sense of what's in there or what are people trying to do. So that's been used quite a bit in integrity. And finally, there is multi-modal, which basically puts, it's memes. Okay, you know this better than I do. Memes put together text and an image, and something funny or hateful or boring occurs, and you need to analyze that. Okay, so let's look at natural language processing real quick. This is going to be our deep dive. So one possibility that you can consider is say, I'm just going to look for certain words in posts. Like if it says marijuana or hate or guns or something like that, I'm going to remove the post. The problem with that is it fails immediately. Okay, it's very brittle, so you can trick the system by using a different word, or even if you're trying to say something about marijuana, how can you talk about the laws for selling marijuana if you can't use the word marijuana, right? Not only that, on social networks, people will on purpose, they will try to misspell words in order to try to trick the system. So that also happens a lot. So the next step is you can look for patterns like I hate blah, or awesome guns, blah, blah, for sale, right? That, as you believe me, is also very, very brittle. You can try to determine the topic of the post, but the topic actually doesn't tell you whether, I can talk about drugs for sale, but it doesn't tell you whether I'm discussing the issue or I'm actually trying to sell drugs. So these are techniques that are very, very useful for all kinds of things in natural language processing, but they're not going to cut it for hate speech or for integrity in general. So machine learning, which is what the entire world is doing right now, is the solution that is used. So let's very quickly talk about what that means. Machine learning is a paradigm where instead of telling the computer exactly what to do, you give it examples. You give it, so take a simple example like photos of cats, okay? So you'll give it positive examples, let's say these are cats, and negative examples that say these are not cats. And the system, using all kinds of techniques, today deep learning and all kinds of other machine learning, but mostly deep learning techniques, will try to find patterns in images that will help it distinguish between cats and non-cats. So you can do the same thing for hate speech. You can do the same thing for bullying speech and other kinds of violations. Okay, so essentially what you're going to do is for every kind of violation, you're going to find posts that are violating. So they're the positive examples. You're going to find benign posts, which are negative examples. You're going to feed them into the machine learning algorithm. The output of the machine learning algorithm is a classifier. The classifier is a computer program that when a new post comes in, it looks at that post and tells you, it predicts whether it's a violation or not a violation. Okay, that's what a machine learning algorithm will do. The challenge here is that you need a lot of examples. You need a lot of positive and negative examples in order to make this work. We're working on many violations. The world is changing all the time. Okay, so COVID comes in and you didn't know about COVID. So now you need to find all kinds of examples of violations that have to do with COVID. So it's very slow turnaround time to get new classifiers and to keep these things current with the state of the world. So then comes a new piece of magic, which is called pre-trained language models. Okay, and there should be a talk just about pre-trained language models. They're pretty cool. You can think of pre-trained conduct of language models as systems that understand how language is used in patterns. Okay, so for example, what you have here is you have the sentence, the cat missing on something map. So a pre-trained language model will look at these words, but it will predict that the missing words are sat and the. So it says the cat sat on the hat. So it knows how to predict which words fit in a particular context. They're not just looking at every single word, they're looking at many, many, many contexts. Okay, they're reading Wikipedia and more. Okay, so the way to think of why are they very powerful? Because suppose you're trying to teach somebody about hate speech. Okay, so if you just use an ordinary machine learning algorithm to teach about hate speech, the system is learning English or whatever language and hate speech at the same time, which is really hard. Okay, it's very hard to learn hate speech when you don't know English. When you use a pre-trained language model, the system sort of knows English already. Okay, it has seen billions of patterns of English sentences, so it's processed English a lot. So now you can come and say, okay, now that you know English, let me show you what hate speech looks like, positive and negative examples of hate speech in English, okay? And now I can teach you about hate speech much faster. So a pre-trained language model sort of gives you a very significant head start to be able to train a machine learning classifier for a particular task. And these things, these pre-trained language models work wonders. It's really all the rage in the natural language processing community. Now, this slide, which you should not take too seriously. This is sort of the state of the art in the field of the sense of humor of the natural language processing community. Okay, so Elmo and Bert were the sort of the first pre-trained language models, and now everybody needs to do something that is a Bert-like or Bert-like character. So this is a chart of all the different pre-trained language models, and there are probably 17 since this was created. I don't know where I stole this from, but it's if you go to Google Images and find pre-trained language models, you'll see this beautiful picture. Okay, let me say 2 words about multi-language content in multiple languages. Here too, we've had a really interesting set of breakthroughs over the last few years. And the idea, and again, going into the details of this is a huge talk, is a separate talk in itself, but the idea is that the new systems that we have can take a sentence, say in English, and map it into a vector of numbers, okay, which you would never understand what that vector is, okay? But that vector of numbers sort of represents the meaning of that sentence, and that meaning is independent of the language that it was said in. And now you have another system that takes that vector of numbers and outputs it in a different language, in German or in Burmese or what have you. So in some sense, these systems are able to encode meaning of sentences in a language independent way, which means that if you have a lot of data for English, you can take your sentences in English, map them into these representations, and now spit them out in Burmese, which enabled Facebook to do a lot of awesome things to help with hate speech and in Myanmar. Okay, so that's a really exciting and pretty recent development that is cool to look at. Okay, I'm done with natural language understanding. I'm going to try to wrap up in 5 minutes. Computer vision. Okay, so computer vision again is the field of trying to detect objects and images. Now, what you're seeing here are 2 photos. One of them is fried broccoli, and the other one is marijuana. Okay, and obviously both of them are these are actual real images that were posted on Facebook. Now, for the life of me, every time I give this talk, I need to check. I go to my notes and figure out which one of these is which. But the computer vision. Now, you could argue you're all teenagers, so if you're anything like my teenagers, you're like, why are you working so hard on this? Broccoli should be banned from social networks as well. But let's say we still support broccoli. So computer vision systems are able to detect between which one is broccoli and which one is marijuana. Now, if we did this talk in person, I would take a vote and see how many of you guessed correctly. But since we're not, I will look at my notes because I don't remember. The picture on the left, the image on the left is the broccoli, and the one on the right is marijuana. So the state-of-the-art computer vision systems can detect that. Let's talk about memes for very quickly. Okay, so memes are when you combine images and text. Now, if you look at this example, everyone in your ethnic group belongs here. Now, that text by itself, there's nothing wrong with it, right? The images of a cemetery. Posting an image of a cemetery is also, there's nothing wrong with that. But when you put that text over that image, that is a hateful meme. This is saying that all the people in your ethnic group should be dead. But the reasoning, right? So it's not just natural language processing, and it's not just computer vision. It's fusing those together and figuring out that that is a hateful meme. So the techniques, so the bottom line is the techniques that are used to understand images and the techniques that are used to understand text are now fused together in these large neural networks. And these neural networks are starting to find connections between text and images and being able to actually predict whether whether a meme is hateful or implies something that each one of the text and the image don't do on their own. That to me is I mean, it's extremely exciting field to be working on today. Let me skip through. So let's look at this one example here. So this is not exactly a hateful meme, but it's there's actually a data set of hateful memes from Facebook that was put out in order for people to actually work on the problem and develop new algorithms. So the one on the left says, you know, love the way you smell today. And in there, the image is of a skunk. Okay, now, is it really enough that the image and the text together, do the image and the text by themselves together actually give us the answer here? Or do we need a third source of information that tells us, hold it, skunks stink, right? So if I'm giving you a picture of a skunk, I'm telling you that, you know, I'm making a reference to the way skunks smell, and then you can make the connection that this is not a very nice meme to put on. So it's not even clear that if you put the image and the text together, you're going to get the answer that you need. Maybe there's a whole source of sort of common sense knowledge that you don't have. Okay, so I'm going to wrap up here. So I hope I've convinced you that first of all, preserving integrity is a huge problem. And the nice thing about the AI community has really rallied around this field, and it's pushing the field forward in ways that are really exciting. There are many other challenges that we're just starting to work on, like how do you do all this when you're not allowed to look at the content, because you're not allowed to look at messages going between two users on Messenger, right? How do you do this in a way that the humans that are looking at content and giving you decisions, you're not harming their well-being. So if you're actually looking at photos of mutilated animals for all day, that's not a good job. Okay, and people should not be subjected to that. Being prepared for changes is a huge challenge, because the world changes all the time, and we need to update our AI systems almost instantly. We're not there yet, but we're working on it. I want to end with one note for the future, which is, you know, we're applying, what is exciting to me about this is we're applying AI to solve or to address a huge societal problem. Okay, it's not just AI by itself. There are a lot of other systems that are collaborating in order to make this happen, but AI is playing a crucial role in solving a big, significant societal problem. And so I'm challenging you all to go and find other important societal problems that AI can also play an important role. So with that, I'm going to end. Thank you for listening.
All right. Thank you, Dr. Halevy, for that wonderful talk. Certainly integrity and privacy and these issues have recently come to the forefront of technology. So I think it's really great that you're able to discuss what Facebook and these other social media companies are doing to kind of tackle this really complex challenge. So just as a reminder to the audience, make sure to put your questions through Slido, and I can just send the link briefly again in the chat. And I'm just going to start off first with actually a question of my own, which is how can AI really prevent the distribution of fake news online? And more specifically, firstly, have there been any attempts to kind of automate that process and like move that away from third-party fact checkers? And if so, what do these sorts of AI classifiers look for?
Yeah, so that's a great question. So misinformation is one of the big areas of integrity that we work on every day, okay? And when we send things to third-party checkers, it's slower because they're not, you know, they're small organizations, and sometimes the research that they need to do is pretty deep in order to make these decisions. One of the big directions that we're working on right now, which we actually do a lot, is a lot of misinformation sometimes is very similar to previous misinformation. So people will, you know, they'll post an article that is wrong, and then a few months later, or other people will post stuff that looks almost the same, or it might be something that was debunked months ago. So if you can, so what we do is when a post comes in and we determine that it's very similar to a post that we know is misinformation, then we'll remove it immediately. And that actually covers a sizable fraction of the content that is misinformation. The other thing that you can do is downrank. So if you're not sure, so we do have classifiers that try to figure out whether something is misinformation. And when we think it might be, and we're waiting for it to be checked, we might, or other social networks might, downrank it in the content. So the probability of people seeing it will be lower. Another thing that you can do is introduce friction in order to share it. So the reason that social networks are so potent in spreading this stuff is it's one click and you can share anything, right? So that means things can get viral very quickly. But if you introduce friction in that point, like saying, "Are you sure about this?" or "This comes from a source that is, has been known to post shady stuff," then you might think twice, because you don't want to look bad in front of your friends either, right? So that's another technique where if you introduce friction, then you slow down the spread of misinformation.
Thank you so much. We have a couple questions from the audience. So one is, let's see, how do legal systems work to resolve challenges with social media problems? And are there specific laws created in response?
I'm a computer scientist. I am a computer scientist, so anything I say about laws is suspicious. I'm not trying to, on purpose to spread misinformation, but the legal frameworks for what is allowed and what is not allowed on social media are still work in progress. And you can imagine that every country has its own spirit and own set of rules, and you need to adhere to what that country requires of you. For the most part, this is still the social networks are actually ahead of the law, in the sense that the policies are trying to define what makes reasonable conversation online. Okay, some of it is actually legal. Some of it is legal, and some of it is legal in some places and illegal in other places. But the system, the product needs to say, look, this is what we're going to allow. You want to say wrong stuff, go somewhere else. Okay, but the laws aren't. The laws are not yet dictating the stuff that has to do with the subtle issues.
All right, thank you for that answer. This is a very different kind of question, but someone in the audience is wondering, what do you suggest for self-learning machine learning? And just like, as someone, what sort of advice would you give to young people who are interested in machine learning and artificial intelligence, and what steps they should take?
Yeah. So there are a bunch of resources online, right? There are a bunch of really good courses that you can take, even on Coursera, that will give you the basics of machine learning. The nice thing is there are a lot of data sets that are available that you can go and you can try stuff. So you and see how it works. It depends on what level you want to understand AI, right? You can understand AI at the level of really what is going on inside the machine learning algorithm, or you could also understand it's like, okay, what can it and what can it not do, okay? Or what can a deep learning system do versus simpler machine learning methods. Another good thing to do is Kaggle is where people post all kinds of data sets and compete on trying to find models to predict certain things that are important to the people submitting the data. So that's a great way to go and actually get your hands dirty and work on real data. So the problem, I think the problem today is not finding the resources. It's more prioritizing and following, doing stuff at your own pace and your own interest. There's plenty of stuff.
Yeah, thank you so much for those suggestions. Going back to what you were talking about in your presentation today, an audience member was wondering if you could explain how the knowledge graph is being used to detect fake news.
Knowledge graph. So knowledge graphs are, first of all, what are knowledge graphs? They are representation of data that we know in the world. So we know that there are certain people in the world. They belong to certain organizations. Maybe they held political office in different places. Okay, so when you can, for example, when you can take a post and see that it mentions certain people, okay, then you have a little bit more context on what that post is. You can figure out that it's a political post, okay. You can even figure out that maybe that post is talking about a fact about that person, which is known to be false, right? And so these things work they're very helpful, but they don't work in too many cases, and they're used sometimes as an additional tool to sort of enrich. Right, you can look at a post, right? You can look at a post and have a classifier that tries to predict whether it's violating or not. But then into that classifier, you can also bring knowledge from a knowledge graph. So now you know that this person is, say, a Democratic candidate for the governor of Arizona. Okay, so that tells you certain things. Okay, so filling in more context is something that knowledge graphs do quite a bit. But usually the facts, the kind of misinformation that you see online isn't stuff that contradicts stuff that is known in knowledge graphs. It's nobody's going to say, for example, we know from knowledge graphs that Paris is the capital of France. Okay, nobody's trying to claim that Berlin is the capital of France. That's not the problem that we have. Now, there is a question, and this is actually a research problem that I'm really excited about, is can we generate knowledge graphs that actually have more subjective, more approximate knowledge in them, and then they can be used much more broadly if you can use them judiciously, right? So you can't take their information as being absolutely correct or incorrect, but they can be a very strong signal to a machine learning classifier. That is an active area of research in the community right now.
Thank you. There's a pretty popular question on Slido right now, just talking about, I guess, like workplace prospects. And it asks, essentially, high school graduates have been signing up for CS majors in large numbers in recent years. And do you think there will be this sort of oversupply as with the tech bubble in 2000?
Honestly, I don't think so. I say that without, looking at the numbers and stuff like that. But all the companies that I've been working at, they're all looking for really good people. There's not an oversupply of well-trained people in computer science. Certainly not in AI, and certainly not in data science. I think that is still a very exciting career path.
Okay, and another question from the audience is, how would AI systems deal with irony? Because there are many posts that could possibly be flagged as problematic, controversial, or fake news, but in a sense, they're just irony. So how would AI really detect those posts?
That's a great question. There are a lot of misinformation. In fact, there was some study that a lot of the posts that confuse misinformation systems or misinformation detection systems are actually attempts to be funny. And trying to detect, distinguish funny from misinformation is a really hard problem. So it's not a solved problem. Let me add another comment to my previous answer. I think computer science will be a great career going forward. What I would like to encourage people is take another, either another major or an important minor, because where a lot of the progress will happen, where a lot of the impact of computer science in the upcoming years will be, some of it will be from computer science, developing computer science techniques that are important, like machine learning, but a lot of it will come from understanding another field and applying computational techniques to that other field. So we're already seeing this in say, biology and medicine, right? But we're also going to see it. We're also going to see it in law, and we're going to see it in possibly the analysis of history and the analysis of literature and all the other sciences. So understanding at a young age those fields, and it's not just the facts and the knowledge of that field. It's also the way people think in that field, because people in computer science, they think in a very particular way. They can tell the computer what to do, and that's the way we do things, right? In physics or in chemistry or in biology, people think in very, very different ways, because they're trying to discover what is true about the world and what isn't, right? So the way they think about hypotheses and how to go about doing experiments is very different. And in the social sciences, it's even more different, right? Because they're trying to look at stuff that is inherently human and subjective and is brittle in that way. So understanding another field, hopefully that you're passionate about, in depth, will be a great asset going forward in a career that in computing.
All right, thank you for that answer. And then there's another technical question on Slido, which is essentially what different methods exist to combine different types of data in a multi-modal model, such as, for instance, text embeddings and image features in an effective way.
So right now, the techniques that people look at are fusing, right? So when you're training a system, you're taking training data and you're giving examples of, positive or negative, right? So now you can take both the text and the image and as input, and the system is trained to combine those two things. So it's just looking at all the features, whether they're text or whether they're image, as the as input. Now, people distinguish between, so you can sort of train the system for text and train the system for images, and then say combine those two at the end in order to train for hate speech. Or you can take the system and say, I'm going to give it text and images from the very, very beginning and train it for hate speech. One is called late fusion, the other is called early fusion. Late fusion is easier to do and cheaper. Early fusion is more expensive but more accurate, because you're finding out connections between the text and the images earlier on, and those are richer. But that is pretty much the paradigm that people are using. Now, I described this to sound very simple, but there's actually a huge amount of depth here and variations that people are trying.
Thank you for that. Just ending off today's talk with one final question from the audience is, one of the final goals of AI is to have those computer programs think like a human. Can you tell us how old is AI now? Like, for example, would you classify it as a second grader or maybe a college graduate?
It really depends on what you're trying to do, right? So in chess, we beat the world champion. In some medical diagnoses, we can do better than expert doctors, but we are not going to let the system replace the doctors. And when you're having a conversation with a system, it's barely, it can't talk to a child yet in a way to engage the child for more than a few minutes. So in certain fields, we've made much more progress than others, which raises the question of, what does it really mean for AI to succeed, right? Do we have to have a system that is just, the same as a human on all tasks, which is, general AI, or do we want systems that are on particular tasks? In some cases, we want them to do better, right? I mean, if we're going to go into a self-driving car, I want that self-driving car to drive better than 99.999% of humans. So that's part of the answer. Another part of the answer is maybe we should flip the perspective and say, I don't want the human to be as good or to compete with I don't want the AI to compete with the human. I want AI that enhances me. Okay, so if I'm trying to make a decision about, say, where to go to college, okay, so I can go and do research and read up on different universities and their acceptance rates and how good their faculty is and stuff like that. But what if the AI system actually went and read all of the web, and it knew me really, really well? It looked at my grades and the comments I've gotten from teachers, and it would say, I'm not going to make a decision for you, but you should look into these 3 colleges because they really fit your values and your interests. So in some sense, it enhances me because it has already read the entire web, which is something I can't do. But now I'm going to be able to make a better decision for what I care about right now. So it's using AI to enhance humans is where I'm personally more excited, and I don't see that competition between AI and humans.
All right, so for the sake of time, I think we'll be ending today's talk here. Thank you again, Dr. Halevy, for your wonderful talk. I think it's really important that we discuss the issue of integrity in today's age, especially as big data and AI become more prevalent in and more mainstream concerns. And thank you again all to our audience as well for tuning in to tonight's talk, and have a great evening.
Very much.
Thank you.
Thank you.
Goodbye, everyone.